Hello, and welcome to today's CryptZone webcast, Network Access Control or Software-Defined Perimeter, or both. I'm Jason Garbis, and I'm going to be your host and speaker today, and I'm joined by our special guest, Randy Rowland. My role is, I've got a long history in software technology, working in a variety of roles ranging from engineering to product management. At CryptZone, I am the head of products, but perhaps more importantly for this broadcast, I'm also active in an industry consortium called the Cloud Security Alliance that has published this specification called the Software-Defined Perimeter. I'm helping to lead the ongoing research work there and develop the evolution of that spec for of software-defined perimeter for the enterprise and for infrastructure as a service. And in our presentation today, of course, we'll be talking about that specification, the software-defined perimeter, and comparing and contrasting it to network access control solutions. So Randy, it's great to have you here. Why don't you take a moment and introduce yourself to the audience, please?
Yeah, good morning and good afternoon, everyone. My name is Randy Rowland. I live out of Dallas, Texas, and I've spent my entire career in IT, most of it working for a service provider that delivered 24/7 data center services in the managed hosting and cloud computing industry. I spent time at VMware, and before that I was the former general manager of Terramark's cloud and hosting division. Hopefully everyone here has heard of both of those companies. We manage mission-critical application for Fortune 500 companies and government agencies. Our job was to keep our customers' most important applications running and secure on a 24/7 basis. And I'm looking forward to the conversation today. I'm actually a little jealous because the solution we'll discuss today I could have definitely used in my previous roles, and I wasn't that lucky, so I think it'll be a good discussion.
Great. Thank you, Randy. So just a reminder, everyone's line is muted. If you have questions, please submit them through the chat panel, through the webinar control panel, and we'll try to address them either as we go along, if they're relevant, or at the end. So if we look at the topics that we're going to talk about, first, we're going to very briefly introduce and define what we mean by network access control, or NAC, and this specification, this architecture called the software-defined perimeter, or SDP. So once we level set there, then we'll look at these two technologies and compare and contrast how they work and their strengths and weaknesses across these four, we'll call them priorities, that enterprises and security teams in particular are facing today. Bring your own device, streamlining the efforts to meet compliance requirements, securing the enterprise against these adversaries that we're all facing today, and accelerating cloud adoption. And then we'll have one short section where we talk about deployment considerations and what these projects look like, and then we'll open it up to questions. So let's go ahead and jump into this. Now, if we think about this, of course, security in general and network security in particular is a very high priority for enterprises today. And we're, as an industry, clearly falling short of where we want to get to. We see far too many breaches and successful attacks that we read about in the newspapers and experience, and there are those of us who have been part of that know how disruptive and expensive they can be to organizations. And I think the next statement, Randy mentioned he's from Texas, and I think that maybe a little bit of the Texas boldness is in the next statement, where we say that traditional network access control solutions can't meet today's business security, technical, and compliance requirements. So Randy, let's talk about that for a minute, because I think it's pretty clear that overall organizations are struggling to meet their security goals. And at the same time, the world has changed in terms of what businesses are trying to do and what users are trying to do. What's your perspective on that?
Yeah, my perspective is historically network security solutions have all been about a trusted user. What we've seen in the past is that companies will build a perimeter around their internal network, verify you are who you say you are, and once you get in the door, you get full access to the network, or at least to a large portion of the network. And that's the biggest thing that's changing today, is that perimeter-based solutions just don't work.
Okay, I think that's a fair statement, and that if we look at for example, the zero trust model that Forrester talks about, it's a notion of you really can't trust users, or at least you can't trust packets on the internal network, and you certainly can't trust the internal network anymore. And this notion of put a high wall at the perimeter, and use some technology to enforce that, and then once someone is allowed on the network, then kind of let them do what they want to do, is clearly falling short of what organizations need to do today from all those perspectives: business, security, technical, and compliance requirements. So what we're, of course, going to be talking about and introducing this call is this notion of a software-defined perimeter. And this is a specification and architecture that was published about 2 years ago from the Cloud Security Alliance, which is a nonprofit industry consortium. And what this does, as we'll drill into it in a couple of slides, is it effectively provides a per-user network segment, an individualized network segment that's dynamically adjusted based on user attributes and network attributes. So it takes the principle of least privilege and enforces it, and effectively allows you to, through a set of policies, that is, in a relatively easy way, give users just the access they need in a very fine-grained way to the resources on their networks. And what this does is, because it's based on policy and not on network configuration or network topology, it reduces the operational costs. Also, because it's location independent, it effectively follows the user wherever they go. It allows organizations to control access uniformly, whether the user is on premises, whether they're working remotely, and whether they're accessing resources that are in the corporate data center or in the cloud. And also helps, because of its visibility and control, to help organizations more easily meet their compliance requirements. So that's kind of the premise and where we're going with this. So let's drill into this so we can see what we're talking about. So first of all, network access control, or NAC. So this is a pretty mature technology. It's been around for quite a while. There's obviously a number of vendors in the space, and the market, while growing, is growing relatively slowly. And the way these things work is it's based on the standard that's called 802.1x, and there's effectively several components of this. There's the client, piece of software that runs on the user's device. That's also called a supplicant. You can see that in the diagram. And what the supplicant does is, when the device plugs into the network, it negotiates with the network access control access point, which is a piece of network hardware that runs on the network. And through that access point, they'll perform authentication. So typically a username and password, or maybe some sort of multi-factor authentication. And the access point will connect with a radius server that validates the user's credentials. And if the user passes this credential test and passes the appropriate device checks, then the access point will allow the user to get access to one or more of these VLANs, or virtual LANs. So a VLAN is effectively a network overlay that defines a group of servers on the network in a way that's enforced at the network infrastructure level, but allows you to logically group together servers based on, for example, risk or on business function or something like that. So effectively what the network access control solution allows you to do as an organization is look at certain set of attributes on the client device, of course validate their credentials, if they have the right username and password or one-time password, and then if the user and device passes, assign the user, that is, give them access to the VLAN. Now, what that means is that, number one, these VLANs need to be defined ahead of time because they're very static, and in some cases they require network configuration changes to alter. Number two, when the user gets allowed to access the VLAN, they get full and complete access to everything on the VLAN. And the reason is that effectively the VLAN is enforced by a network switch that's either allowing or disallowing packets through to everything on the VLAN, but there's no filtering beyond that. When servers are created, they get assigned to a VLAN based on where they're physically located or what network switch they're attached to. What's important around this is that, number one, most organizations have a relatively small number of VLANs, 2, 3, 4. They might have a guest VLAN, a regular employee VLAN, and then a high-risk kind of production VLAN. But organizations don't have dozens and dozens of VLANs. Also, the network access control solution does not and can't extend to resources that are running in the cloud. The way it works, it operates at a relatively low level in the network. Cloud, in particular infrastructure as a service networks, don't operate the same as on-premises networks, and NAC solutions can't extend to those. So what that means is if organizations are using cloud-based resources, they have to have an alternative and additional solution other than NAC to be able to manage user access to those things. NAC also doesn't provide for secure access. There's no encryption of the traffic. There's no support for handling remote users. So that means, again, if you have some users who are remote, which of course is the case for every organization, that there needs to be yet another solution like a VPN that's added into the mix, and that's yet another set of policies, another set of policies that have to be managed. So let's compare and contrast that to the software-defined perimeter approach. So the software-defined perimeter effectively will draw and dynamically create an individualized network segment of one for each user. So like the NAC, there's a piece of client software that runs on the user's device, and there's a set of there's a component that runs that device will authenticate to, called a controller, using typically multi-factor authentication or integration with an organization's identity management system. And then the software-defined perimeter system, through a series of gateways that protect each of these server resources, will allow or disallow user access to these resources. As you can see pictorially in the diagram, these perimeters for each user are individualized based on the user's profile as well as attributes of the server resources in question. So unlike the coarse-grained approach of a NAC, which maps users to everything on the VLAN and every service and every port they have access to, with a software-defined perimeter, it's very individualized. And these individualized perimeters can, of course, be overlapping. You can have multiple users who have access to the same server, maybe even the same services, or perhaps the different services running on the network. So in our example here, we have this individual on the right-hand side who has access to a number of resources, some of which are in the cloud and some of which are on premises here. And then the gentleman with the beard in blue and green, who happens to be remote, also has access to a set of services. He may well have different access to that database server than the blue individual there. He might be a business user and can access I don't know, one port to do some data queries, whereas the other individual might be a system administrator and can access different ports or could SSH into the server. So what this does is this allows organizations to get the kind of fine-grained control that they really need for security and compliance reasons, but do so in a way that's based on policies and not on these very coarse-grained VLANs, or to try to do it through traditional firewall rules, which is effectively impossible. They get very difficult to manage. Finally, the software-defined perimeter will also automatically adjust to changes in the infrastructure. So as new server instances are created or instantiated either on premises or in the cloud, those attributes around the services will be taken into consideration and users will be granted or denied access appropriately. If we look at this in action, effectively, there's a notion of a digital identity that's built around the user that combines a set of attributes around the device, their roles in the organization, the permissions that they have, as well as attributes that are driven by what's happening at the exact moment in time when they're attempting to access, whether it's geolocation, the time of day, or whether things are running on a certain device like antivirus software, for example. And then once it authenticates, this gateway that I mentioned establishes this encrypted tunnel from the user's device to the gateway so that all that traffic can pass over unsecure networks like the internet without any concern. And the gateway will manage access to the set of services and adjust what the user is allowed to see and do based on policy. So in this example, the user can only access one particular point on the ERP system. All those other services that exist on the network are inaccessible to the user. So it's very fine-grained control of the user. And as things change, the user's access will be adjusted. Okay,
Jason,
so that, yes, Randy.
But before we move on, so I think the best way to compare what you would get access to between the two technologies that Jason just highlighted is if you had a network port scanner and you were to connect to through the NAC solution and assign the VLAN and run a port scan, you would see every single network port and service available for every server that's in that VLAN from your machine. If you were to do the same activity, do the same test with a software-defined perimeter, the only ports that you would see available are the ones that you have explicit rights to from through the digital identity, and everything else would be completely invisible. And so the actual number of targets that you have, and we'll talk a little bit more about this later, would be substantially reduced. That's the best way to think about it.
Yes, and that's a great point. It's around reducing the attack surface area and hiding these systems, only exposing them to authorized users who we validated through multi-factor authentication. Great. Okay, so now let's dive into kind of the discussion part of it. So we've identified these 4 priorities that we've seen very consistently being raised as among security teams and enterprises, and these may make their way appear as a funded project or as an initiative or as an overall strategy for the company, whether it's enabling bring your own device, streamlining compliance reporting, whether it's, of course, reducing the attack surface, which needs to be an ongoing effort for everyone, or accelerating cloud adoption, which is very often driven by the business and the need to embrace the much more the DevOps style of building and delivering software, which can deliver a lot more value to the business much more quickly. So let's talk about each of these things. So when we mention BYOD, of course, the way we're defining it here is about organizations letting employees and other authorized users, who of course may be contractors or vendors, to get access to corporate resources and corporate networks with devices that a company hasn't purchased and a company hasn't provisioned. And this, of course, is a fairly unstoppable trend. I think we all have experienced it, and it brings with it some challenges. In particular, making sure naturally that only authorized users and permitted devices can access resources on the network. That's kind of fundamental to security. And it's also about getting visibility into the devices that are on the network to do, whether it's an inventory or just a validation or maybe for compliance reporting purposes. And of course, organizations need and want to have these things integrate with existing authentication systems for a variety of reasons, whether it's to consistently enforce single sign-on or to enforce user access controls or to tie into the identity lifecycle so that when people join the organization or leave the organization, they get properly provisioned and deprovisioned across all these systems. And nobody wants someone who leaves the organization to be able to access corporate resources after they've left from their purchased device. So Randy, do you want to give some perspective on this? I know that in your experience, there's been a lot of interesting challenges around this.
Yeah, I'll give a few comments. So bring your own device policies are a real issue for service providers, and I think enterprises alike. In some cases, it's actually becoming a recruiting tool to attract top IT and security talent. In the early days at Terramark, we had a policy that you could only connect to our network with a corporate issued device. And remember, most of the engineers we had were IT engineers that were managing customer infrastructure. So we had to be very serious about security and make sure that we don't have any unauthorized access to our customers' systems. But it was very difficult to enforce for a number of reasons. One is engineers whose primary job is to troubleshoot problems, they actually want full flexibility on the type of hardware and operating systems they use. So I think many people on the call today probably have this, resonate with this. They want a lab. They also want to be able to test things on their own machines before so they can start troubleshooting. And so even when we would deploy a corporate issued device that was blessed from IT and had the right operating system and everything perfect, a lot of times they would tear into it and make changes. It was very hard to manage. And then you also have the issue where you have a top engineer who's on vacation, or here in Dallas we have ice storms, who couldn't make it in the office and they don't have their corporate issued device with them. And so somehow they've got to connect in and resolve a problem. And so over time we actually switched and we went to more of a bring your own device policy. And I actually was talking to a very large service provider the other day. They actually have rolled that out, and it's considered a perk as part of joining their business, which is, you can pick your own device, your own operating system. So if you do that, what you need to do is figure out a way to actually control this and make sure that that they meet minimum requirements before you connect them to any network resource. And the other thing that engineers are doing today, they're doing more and more on their mobile devices, on their iPhones or their Android devices or their tablet. It's becoming more and more common. So what you want is the ability to set a policy to ensure each device meets a basic security standard before you can provide a network connection. So examples would be, is it running an approved OS, and is the OS patched? Did you download our antivirus client or any type of endpoint security agent and make sure it's updated and running? Is the OS firewall enabled? And then, several other things, but one of the things you also do want to understand is what ports and what applications will you access from this device, and how is that determined? And these are all things that companies are interested in, and if they can remediate, if they can use this software-defined perimeter approach to remediate the device and make sure it's at a minimum standard and that you can verify the engineer is who they say they are, then I will let you connect to a subset of solutions, and we'll talk a little bit. You can be very fine-grained. We'll talk about this later. You can even use external databases like ticketing systems to say, hey, you can only access this system while this ticket's open. There's a number of things you can do to enable BYOD, allow it to be a perk, allow it to be something that you're having a hard time controlling, and still ensure that the security meets your standards.
Yeah, great. Thank you, Randy. I think that in a multi-tenant service provider environment like you were, you're seeing the same problems really that enterprises are. They're just amplified and magnified. So they've been, your pain was probably more so than most enterprises have, but still, very relevant. And these are real and very clear problems that organizations have today. So let's take a look at some attributes and compare and contrast what these things look like with a network access control solution and with a software-defined perimeter. So the first is that with the NAC, of course, you get visibility of devices on the network. Because NAC works at the network layer and will only effectively give IP addresses to approved devices, these solutions do give you visibility of that. Whereas with the software-defined perimeter, it operates at one layer up in the network, where once a device is on the network, it communicates with the SDP infrastructure, and only after it's validated and authenticated will it be able to get access to any resources that are on the network. So at the NAC layer, you get visibility. They provide visibility of what devices are attached and have IP addresses. With the software-defined perimeter, you get visibility into the devices that are actually accessing the network resources. And unauthorized devices, while they're on the network, they can't access any resources because those resources are protected by the software-defined perimeter. Both solutions provide different levels of validation of the device profile. NACs are known for having, through the client, the ability to interrogate some attributes and report on some basic things. Software-defined perimeter, as a specification, talks about doing this, and as a vendor who's implemented an SDP implementation, of course, in our product, we filled in some of the gaps of the spec and have extended that to be able to support not only device attributes, but user attributes and the ability to pull in a much broader picture of the user from directory sources or from other environmental systems. Authentication happens with a NAC through this standard called the 8021X, and there's obviously a couple of standards around that mention how the various pieces interconnect and talk on the network. And that is helpful, has been helpful over the last 10 years because it helps organizations able to mix and match network equipment and NAC solutions from different vendors with varying degrees of success. But it also constrains the systems. And if you look at how software-defined perimeter does it, this is built to be extensible and integrate with both on-premises identity systems, whether they're Active Directory or LDAP, or standards and federated systems that are based on standards like SAML. And what this allows SDP to do is to connect up to not only one enterprise's identity management systems, but to third-party or cloud-based identity systems. And this is really important when we start to think about third-party or contractor access to a network. So with a NAC, it's really limited to the one silo that the NAC can talk to, whereas with a software-defined perimeter, you can have a contractor who comes on board. You can validate them by authenticating them against their organization's identity management system, doing this securely in an open and standards-based way across the internet. and then you can make sure that they're validated, and that when they leave that organization because they go find another job and their organization turns off their access, that you're not inadvertently leaving their access open indefinitely because you don't find out that they've left the organization. So it's much more flexible, much more robust when you can tie not only to authentication systems, but to the actual identity management systems that are running the business process of joiner, mover, and leaver. And then we talk a little bit about the granularity of control, how with Mac Solutions, it's providing all or nothing access to resources, to all the resources on a VLAN, whereas with the software-defined perimeter, you have policies that control in a very fine-grained way which users can access which services running on various servers. And the nice thing about with the SDP is that these policies are based on attributes and descriptions as opposed to hard coding things based on servers and resources. Randy, thoughts on some of these aspects?
Yeah, so a couple comments here. One is this concept of authentication via identity system integration or other third-party databases would have been a huge benefit for us because to your example of being an employee, we have employees as a service provider that we can authenticate through our directory. If we could have also verified through our internal, not all permissions that we leveraged within our environment were in the directory. Sometimes they were within our customers' applications. Sometimes they were within our own third-party databases like ticketing systems. So if I had an engineer with his bring your own device that I could remediate to make sure it meets basic security standards and use a combination of different identity systems and third-party databases to determine what they have access to, it would have been of huge benefit, and this concept of creating a dynamic perimeter per user would have been very powerful, because if you have hundreds of engineers who are providing 24/7 services to hundreds of clients, being able to create a unique perimeter for every single engineer to make sure they only had access to what they needed to, I think would have increased the security both for us and our customers, and even been better security than probably what they had internally in their own environments.
Yeah, I think that's definitely the case, and that helps. It would actually also help with compliance reporting, which takes us to the next section here. So when we talk about compliance or compliance reporting, many, I would say, majority of companies out there are subject to various regulations, whether they're publicly traded companies or whether they're operating in certain sectors of the industry that have regulations applying to them, whether it's healthcare or they handle credit card data. And effectively what these organizations need to do is to reliably and regularly report on who had access to what and when for these types of data and applications. And this is a big challenge. I've seen this 6 years ago when I started working in identity management and identity governance, and it's certainly continued to be the case that this can be a pretty significant compliance reporting burden on organizations. And trying to understand and map what users have access to across the network over time is very difficult, especially when you're in an environment that has multiple network technologies and network tools that, by definition, aren't working at the user layer. They're working at the IP address layer. And it gets very difficult to consolidate all this into a report that makes sense to the auditors who have to look at this. It tends to be a very big and effectively non-productive drain on IT operations and security teams. And so what organizations have to do, of course, is demonstrate that they have these technology and process controls to prevent unauthorized devices from accessing network resources and to enforce segmentation of their network. And this is particularly important for things like the payment card industry data security standard, PCI DSS, where you have to manage these cardholder data environments very carefully. You have to define them and be able to control who has access to what and from what devices into those segments. So those are real challenges, and I'm sure you encountered a lot of that in your experience, Randy.
Yeah, so at Terramark we had a full department focused only on helping not only our company but our customers meet their regulatory compliance standards and to pass their audits. And you mentioned this earlier, we had a more complex environment than average because we were multi-tenant. And so many of our customers who had these stringent regulatory compliance standards, we had shared infrastructure that we had to prove compliance on. And so I still remember specifically the effort we had to go through when we needed to produce the report that showed every user and what access they had to every part of a back-end application. We had to pull logs from the application servers, from the server operating systems, from the firewall, from the VPN, from the Active Directory or the directory service, and several other sources. And the problem is that most of the network access was still IP-based. And to correlate when someone connects over a VPN and a firewall and track that individual person in every single place they may touch on the network, it was really difficult to do. The report was never perfect, but the one thing for sure is it took a lot of time and effort to build. We were able to get through the audits because we had a pretty tight security approach in the network, but it was just very difficult. If we had logs based on the SDP architecture that could tell us precisely who had access to what and for how long, and the context of the device when they connected, then it would have been the ultimate solution, because effectively it would reduce the entire research project that we had to go through to actually correlate all these different data systems into a single repository and create a report. So to me, it's the ultimate log to show proof of compliance for every user and what they access on the network.
Yeah, thanks. I know that in some enterprises, this is a multi-man-month effort. If you look at the number of people and the amount of time they have to spend collecting this data and consolidating it and making sense of it, and to reduce that by even 40–50% is a huge win. And we've seen organizations reduce it by about 90% when they can just get this user-centric view that shows very clearly over time exactly who accessed what and who can access what. So let's go through our list here. Now, in both cases, both NAC and the software-defined perimeter will validate users and devices through different levels of attribute checks as well as authentication before they can access things on the network. And again, from a technical perspective, NACs and SDPs do it a little bit differently. With a NAC, an unauthorized device will not be able to obtain an IP address and send packets on the network. With a software-defined perimeter, the device needs to be on the network, communicate with the SDP infrastructure to do the validation and the authentication. Once that's done, authorized users can get to these resources and unauthorized users won't. And there's some technical approaches that SDP takes to secure itself from unauthorized or perhaps malicious devices that are plugged into the network. So in both cases, the resources are protected. They're just done with slightly different technical approaches. In NAC, I think Randy expressed very well some of the compliance reporting challenges and how you may be able to get some reports from NAC, but they are tied to IP addresses, not to users. And it's very challenging for organizations to create this end-to-end view or end-to-end clear picture of when Joe Smith, who works in accounting, accessed what resources on the network, as opposed to this IP address, which was assigned to Joe today and will be assigned to Sally in development tomorrow. With SDP, of course, we do get that full user-centric view. Because the traffic is managed by the SDP system from the user's device where it initiates to the gateway, and then from the gateway only to the target server, there's a clear end-to-end view of what users are accessing when. That's going to be reliable and audit-proof. And then we talked about this consolidation that has to happen, and Randy was kind of enumerating all the different systems that they had to pull information from, whether it's a VPN concentrator or an application server or a network device, versus one unified place to do that with an SDP. It's just much simpler and much clearer and much easier for everybody. Finally, one of the nice things that what we've seen our customers benefit from is that this fine-grained control of what users get access to can help significantly reduce the audit scope. So rather than auditors coming in and saying, okay, we need to look at everything in your data center or everything on this VLAN, the organization can say, we've got this technology in place, and you can see these policies here, and it reduces access, it controls access to those sensitive servers to only this small group of users. So it significantly reduces the scope of the audit, meaning it's simpler, it's faster, and it's less expensive, because these auditors are third parties who charge by the hour. So Randy, any thoughts or comments on that?
No, the only other comment I'd add is, Jason always says people are not IP addresses, and so as long as you're trying to show proof of compliance and you have reports that are based on IP address ranges, if you can add the actual user and what their permissions are, and be able to track it where IPs are secondary, not primary, it really increases the ability to prove compliance. And one of the things we hear regularly is it's hard enough to do it internally. If you start connecting your internal network to cloud resources, that makes it even more difficult, which I think we're going to talk about in the next use case. But the ability to say user by user and IP is secondary, not primary, makes a huge difference in improving compliance.
All right, terrific. Thank you. So let's shift gears and talk about the attack surface. And we all, unfortunately, read about in the newspapers practically every day the latest breach, the latest hack. And I think enterprises are really and legitimately very concerned about this. We also know that the challenges around this, of course, are protecting our applications from attacks. And we know how easy it is for adversaries to get a foothold in the organization. It's not hard to craft a phishing email, and all it takes is one user to click on this, and then they have a foothold. So you can't rely on the perimeter anymore. At the same time, you can't lock everything down. You have to balance security with business efficiency and the IT operational workload. And I think that we saw recent articles about the Yahoo breach, where they, in retrospect, clearly made the wrong decisions about balancing this and didn't invest enough in security, and unfortunately paid the price with this very large breach of user information. At the same time, I think related to business efficiency and business productivity is you can't only restrict this to your employees. You have to let your customers or partners or suppliers or contractors get access to your internal applications if you want to do business. And of course, you need to be able to have a system that when anomalous behavior or malicious behavior is detected, can help respond to that. It can help inform your security operations center or your SIM system, or it can help provide those with teeth to shut down users or quarantine users or things like that. So Randy, I'm sure you guys have thought about this a lot in your sophisticated environment.
Yeah, so at Terramark, we were managing our customers' servers and their applications on their behalf. And the way that our architecture work is that every customer would get a minimum of 2 private VLANs for us to manage, and sometimes they would go up into the hundreds. And so what we had to figure out how to connect securely to these VLANs so we can manage their applications. But we also had to create a number of specialty administrative networks to manage everything. As an example, we needed network access to provide monitoring, to do backup. And because we did not have the capabilities of the software-defined perimeter that we're talking about today, we were constantly adding new networks to try and minimize the attack surface. The way I always think about when I see reduce the attack surface, to me, in my mind, an attack surface is a VLAN and everything laterally on that VLAN. That is an attack surface. So if you have a large management network, if you put another VLAN, you just cut the attack surface by half. Well, over time, that got overly complex. If you're always trying to reduce the attack surface and you've got literally tens of thousands of applications, hundreds of customers, each with multiple private VLANs, it literally becomes, you almost have to be Neo in the Matrix to figure out what's going on. And the actual network that I probably was the most worried about is the lights out network. And we used to be a big customer of HP servers, and HP had a separate board they would put on every server that had its own battery backup and network adapter that allowed you to connect over what they called lights out. So if the server ever failed or blue screened and you couldn't get it to respond, you could come underneath the operating system and get access to the system. Many server vendors have similar technologies. I think Dell has a DRAC board. There's a lot of different technologies that allow you to get remote access out of band. And that was the network that I probably lost the most sleep over, because we needed it. We needed to be able to remediate a device if for whatever reason it had a problem, but it also had to have a network that got access to it. And so that's the thing that probably created me the most heartburn. If we had the software-defined perimeter, what we would have done is put a gateway or an AppGate gateway, which we'll talk about AppGate a little bit later, in front of the lights out network, and we would require a ticket be open for a specific server before we granted a one-time network entitlement to get access to that system. Because just having a flat network on a lights out or a network like that is just, it's literally terrifying to think that someone can get underneath the operating system and take control of a system. And so that's an attack surface that I was very concerned about, and that's an example of how you could massively reduce an attack surface and go from potentially hundreds or thousands of touch points to a single point that's controlled tightly with an external system.
So that's that lights out network, or the what's called the baseboard management control network, is we sometimes jokingly refer to it as the dark matter of of the attack surface, because it's there for many enterprises that buy these server class hardware from the major manufacturers. They all have this. You're right, and it's a pretty well known area that is not very secure. And what I mean by that is, first of all, most of those, in fact all of them, are shipped with default passwords, and everyone knows what the default passwords are because they're in the manuals. Second, they may or may not force you to change those passwords, and at best these organizations offer single factor authentication or can connect up to an identity management to an Active Directory or an LDAP system. Most organizations, I would say many organizations, don't do that, and if they change the passwords, they end up being shared credentials because they're not tied to individual users. So you're right, Randy, it's very easy for attackers to get on the network, find that lights out network, and then it's, in most organizations, easy to find servers that have default passwords, aren't well protected, or could respond to brute force attacks or something like that. And then once they're in there at the hardware level, it's trivial for them to add new files into, add new executables because they have access to the file system, and next time the machine boots up, they've got a foothold and they're off to the races. All right, so let's take a look at those things. So with network access control, of course, we've talked about this, how users get all or nothing access to a VLAN, and organizations don't have a huge number of VLANs because they're challenging to manage, and especially for older network equipment, they require hardware changes, changing what cable a server is connected to, what port it's connected to on a switch. Whereas with SDP, because it's a full software overlay, it works with effectively any network topology and gives you very fine-grained access control. So if Joe Smith gets compromised with a NAC, this attacker can get access to, at a network level, all the resources on the VLANs, whereas with a software-defined perimeter, all they see are the 5 or 10 applications and those ports that Joe has legitimate access to. So you've reduced the attack surface area very, very considerably. Second, for third parties, which comprise a pretty significant chunk of most organizations' users, whether they're vendors or contractors or customers, it's hard to manage that for NACs. NACs, of course, can do this device validation that we talked about, but it only will grant them access to the full VLAN. In most cases, these third parties need access to a very restricted set of services and applications, and it's very straightforward to do that with a simple policy in software-defined perimeter. NACs also don't solve at all the problem of secure remote access, whereas with SDP, the network traffic is encrypted and tunneled from the user device to the gateway. So you can have any user, whether they're a third party or an employee, given the same level of security with access to internal applications, whether they're on premises or remote, with one policy and one solution. It's a far better and far more comprehensive solution. And that's why we're certainly seeing organizations replace their VPNs with the software-defined perimeter to replace not just the secure remote access aspect of VPNs, but the overall secure access control that it provides. And as we mentioned with the NAC, you have to have a separate VPN solution that's going to be disconnected and doesn't provide a cohesive and comprehensive view. Finally, as servers change, especially in a virtualized environment, it's difficult for NACs to keep up with that. Whereas with the software-defined perimeter, when a server is created, it's going to be sitting behind a gateway. It's going to have attributes associated with it, and policies that already exist in the SDP will automatically be applied. So if a new server instance is created and it's tagged as development for Project Eagle, then it's going to automatically be added to the list that users who are authorized to those groups and those policies will be able to get access to it. Finally, we talk about anomalous behavior detection, and both these systems can and do integrate with SIEMs or with systems that a security operations team might be using, and can adjust to them based on these kind of outside activities. So in the case of a NAC, the reaction is, okay, let's quarantine this device, and won't let it access things on the network except perhaps the IT help desk, for example. With software-defined perimeter, of course, we can do that. We can also have a more flexible set of responses, such as if anomalous behavior is detected, again, many times the team doesn't know whether this is a legitimate anomaly, it's an attacker, or it's a false positive. So in these cases, the SDP solution can incrementally raise the bar, for example, to prompt the user for a one-time password. That's a very good way of distinguishing very quickly whether this is a legitimate user who has their second factor or whether it's an attacker. That way, you can help reduce the impact of false positives, which are an unfortunate aspect of any security system. Okay, so now let's look at the last scenario around accelerating cloud adoption. We're talking both about on-premises cloud environments based on like a KVM or a VMware environment, as well as public cloud based on infrastructure as a service, things like an Azure or an AWS environment. In both these cases, this is very, very rapidly being adopted by organizations. You look at the growth rates that the IaaS providers are encountering and some of the data that researchers are publishing around enterprise adoption of private cloud. This is an unstoppable trend. And the challenge with this is, how do you secure access to this? Because number one, in the case of public cloud, it's off your network. And number two, for both those environments, these servers are changing much, much more rapidly than traditional hardware-based servers. So how do you control and log user access to these dynamically or newly launched servers? How do you categorize the applications to make sure that people get the right level of access? And how do you do all this and give the users the productivity benefits without over-entitling them? So Randy, you obviously worked in a very advanced and pioneering enterprise cloud environment. I'd love to hear your perspective on this.
Yeah, and I know we're running short on time, so I'll be quick, but when we launched the enterprise cloud, obviously security is something we tried to address, and we heard from our customers all the time. And most companies start with deploying new web-based applications that they don't want to host internally, but they're not really considering moving anything material to the cloud until they get more comfortable with security. What I would have done with the software-defined perimeter, if it had been available, is built an entire Cloud Connect product offering that would not only leverage our cloud security features, but also leverage our customers' internal directory services to determine who had access to what network permissions that we can give out. And ideally what you would do is application permissions, the network would match access exactly to who should have access to what. And many of the new cloud providers like AWS and Azure, they all have network security groups or security groups that could be tied into a software-defined perimeter very easily. And effectively what you could do is create a perimeter around every single user that access every single resource within the cloud environment, and then produce a report showing compliance on precisely who had access to what. And that report by itself would encourage companies, because it's so difficult to produce internally, to actually trust and move more and more of their applications to the cloud. And then there are companies that are using cloud specifically for certain purposes, and they'd still like to see those compliance reports, and those can be achieved through a software-defined perimeter that's deployed in a hybrid environment to control not only network access to cloud resources, but also network access to secure assets within the walls of the data center as well.
Yeah, I think we've certainly seen, both from enterprises that we've spoken to as well as the cloud providers themselves, that security and compliance is an ongoing concern and is absolutely a barrier to further adoption of the cloud. So let's compare and contrast these real quick so that we're running up on the end of our time here. So with a NAC, again, it's all centered around these VLANs, and as virtual machines are created, they get assigned based on effectively the way that they're spun up and the network interface card, the virtual network interface card they're assigned to in the VM. And as always, it's all or nothing access. And while it's possible to assign servers to multiple VLANs, it gets complex pretty quickly from a hypervisor network configuration perspective. And you compare that to the SDP, of course, there's no notion of VLANs. It's all about policies, and you can have an unlimited number of policies that apply to an individual service or an individual server, and those policies get automatically applied based on metadata, attributes about the server, attributes about the environment, and attributes about the user. So there's no decision that has to be made when a server is created that kind of sets things in stone, which is how it is with an NAC. It's much more dynamic and based on attributes that change and can change over time. And that's really the biggest and most disparate difference if you compare trying to use a NAC to control access to a private cloud versus using a software-defined perimeter. A software-defined perimeter is really designed for this kind of policy-based and dynamic environment. And then we look at public cloud, NAC can't apply to that. These infrastructures as service providers, first of all, they're remote, so you have to go across either the public internet or a lease line private network to get there. And number two, they're not standard networks. They're highly virtualized. They're not standard layer 2 networks. So NAC technologies, the types of things, components that we mentioned earlier, simply don't work in that environment because they operate at a lower level than what these IaaS providers support. Whereas with SDP, it's designed precisely for this and gives you a way to, in a seamless and unified way, control user access to on-premises and virtualized and physical and remote cloud-based resources with a single set of policies and a single set of users. So let's kind of have the brief overview of the deployment considerations. I know we've only got a few minutes left, but in general, what we've seen, what we've heard from customers, and what analysts talk about is that NAC deployments are really challenging. And this has been consistent for probably 10 plus years because it's based on this 802.1x standard and because that standard needs to be supported by the network infrastructure, whether it's hardware, network hardware gear, or whether it's a software layer on top of that. It often requires upgrades and a consistent level of hardware support for that standard across the network. It makes it difficult to roll out and expensive and difficult to manage these policies because they're managed and enforced at the network layer. We compare that to the software-defined perimeter, which is a complete software overlay. It sits above the network infrastructure, and it works with effectively any network topology. And it's very easy because it's based on users to roll it out incrementally. We have some customers with very, very large user populations who start with a focused area of 100 or 200 users and a small set of resources, for example. They can get moving in 2, 3, 4 weeks very successfully, which compares very favorably to the 9 to 18-month typical deployment cycle for NACs, which are all or nothing because those services, the network hardware, has to sit in line and manage access for everything on the VLAN. Any comments on this, Randy, before we wrap up?
No, I think we're running out of time. My only comment is a software overlay is easy to implement, requires no network changes, and what we've seen with our clients, when they start deploying this, they can actually reduce some of the complexity on their existing network and over time create a more manageable network because there's not near as much complexity in managing all the different IP range access to access rules.
Yep, absolutely. Okay, so let's debate this for a moment. Can these things coexist in an environment? So technically, yes, absolutely. No reason they can't coexist in the environment. think the question really is, should they coexist? And it's clear based on, I think, what we've been talking about, and also based on the kind of conversations that we've had with enterprises that are really struggling with, is that if they have an existing NAC solution, very often they have challenges around it, they're dissatisfied, or they have it only partially rolled out, and they look at SDP and say, this is great because I can leave my NAC in place for what it does today, but for the new scenarios, whether it's public or private cloud or the fine-grained access control and compliance reporting that I need, I can start to use software-defined perimeter. I don't have to replace my NAC solution. I can just kind of contain it and continue to get value out of it, but not invest any more in it. What's a more interesting debate is organizations that don't have a NAC but are looking to solve their network security solutions. Then it becomes an either or, and we very clearly see that organizations are shifting away from NAC and looking at SDP because of all the reasons that we've talked about. There really isn't a compelling reason to deploy both of those based on the lower cost of ownership and the better flexibility and the unified support across hybrid environments that the software-defined perimeter provides. So we're going to wrap up here. Randy, any closing thoughts on what we talked about?
Nope. I know we're running out of time. I don't know if there's questions that people want to submit in the chat window, but I know you probably have a couple closing comments, Jason. Yeah,
exactly. So just to wrap up, folks, I think that if you have questions, we will we can take a look at them and respond by email since we're just about out of time. I think we've made the case and talked about how network access control solutions are really challenged because they're based on older technology and technology that was designed for the world that no longer exists around rigorous and robust perimeters and a trusted internal network that's relatively static. It really can't meet today's requirements, and that a new approach around software-defined perimeter is necessary. And if you look at what organizations are doing, what the Cloud Security Alliance is doing around the software-defined perimeter, what industry analysts are saying is pretty clear. I mean, Gartner just published a research report last week that talks about this, with a prediction that by the end of next year, which isn't that far away, the percent of enterprises that are going to use software-defined perimeter is going to grow from what's less than 1% today to at least 10%. So that's a huge growth that we're seeing in the adoption of software-defined perimeter. And I think it's leading organizations are certainly recognizing the value that they get out of it. So to wrap up, I think that many of you are familiar with CryptZone. For those of you who aren't, we are an enterprise software security company. We have three main products. You can see them on the right-hand side here. So if you visit our website, the product that we're talking about today is our software-defined perimeter product called AppGate. We also have two other solutions called Security Sheriff that provides SharePoint data loss prevention, and Compliance Sheriff that provides website compliance, particularly around accessibility. And with that, we'd encourage you to check out our website. We have additional resources that I think you'll find valuable, whether they're case studies or white papers or our blog. The software-defined perimeter solution, which we call AppGate, is also available in the AWS Marketplace, and we encourage you to check that out. And with that, I think we will wrap up based on being out of time. Thank you.